Hello, everybody. This is Aaron Schwartz, and I'm a secondary math specialist with Montgomery County Public Schools. We're going to do a follow up video today. The previous video, Making a Point, was about deriving point slope form. This time, in making another point, we're going to have slope intercept form derived from that point slope form. In Unit 2, Topic 2, students learn to build equations recursively and explicitly as descriptions of recurring patterns. The key ideas include that equations can be used as succinct descriptions of a pattern. Some of the helpful skills students have already learned include proportional reasoning with integers and rational numbers. This is done in Math 6, Math 7, and IM. Coefficients represent the number of addends of a number. This is done in elementary school and Math 6. A number can be decomposed to reveal patterns. This is a skill extensively developed in elementary school and very useful for this video and other parts of Algebra 1. Let's take a look at a typical example. We're starting with the table of values. We have our initial value at x equals 0. You'll notice that each time we're increasing by 3. So the goal is to develop an equation for any situation. However, we don't want to just tell students what the rules are. We want students to have an experience where they're able to deduce what the rules are. That way, they have ownership over it and can explain where the rules came from, not just what the rule is and how to use it. We're going to take a particular look at 0 and -7. When we use our point slope form, we can come up with the equation 3 times the quantity x minus 0 minus 7. Notice that this can be simplified because x minus 0 is just x, and it simplifies to 3x minus 7. In other words, our slope and that constant for when x is 0. This is particularly useful. When we go to graph it, we're going to notice that the y-intercept also happens to be -7. At this point, we might be able to conclude that if we're given an equation in terms of a coefficient or slope times our variable, and then a constant, what we really have is representative of the initial domain of 0 and that particular range value, or the y-intercept. Thus, things that look like y equals mx plus b is always the y-intercept. That can be very difficult for students to grasp on just one example. So we're going to go to Desmos, and we're going to use Desmos to explore point slope form. Slope intercept form. I'm going to go ahead and start graphing, and I have a pre-made example that I'm going to open up. Here we go, slope intercept form. In this particular graph, I've identified the point that is always the y-intercept, and I've created sliders to represent the slope and the value b. We'll be moving just the value of b for a bit and observing what happens to the y-intercept and to the equation. As I move b up, I'll notice that the line is moving up. It's translating up. I'll also notice that whatever my y-intercept is, 4, happens to be the constant that's added into the equation. Even when I change the slope, the constant at the end does not change. This means that when I'm given the equation y equals mx plus b always represents the range value when x equals 0, or simply the y-intercept. And that slope doesn't change the y-intercept. I hope that this video helps teachers create classrooms where students explore math, observe patterns, and develop conceptual understanding. If you have questions, comments, or have a video idea, please email me at the address below. Thank you, and have a nice day.